Hi everyone, and welcome to the third Backend Fundamentals video. In this video, we're going to be setting up the Flask project on your local computer and getting it running and explaining all of the lines of code, just so you know exactly how it works. So the first thing that we're going to need to do is create a new repository on GitHub. So we can do that by clicking the plus here and clicking New Repository. In this case, we'll name it maybe something like ZotHacks Video, or maybe ZotHacks Project. And we'll leave everything else as is, since we're going to be overwriting a lot of this stuff with the template that we provide. So once we have the repository made, we're going to go head over to the ZotHacks 2020 prerequisites document. We'll click on the backend bookmark, and we'll click on the GitHub code here, or GitHub URL here. From here, we have two options. We can either download the code as a zip, or we can use the command line. They both result in the same thing, but I'll show you how to do it in the command line as well. So in this case, we'll want to make sure to copy the URL seen here by clicking this button. And we can simply git clone and paste in that link. As you can see here, within this path that we have set, that I preset, it's going to create a new folder called ZotHacks 2020 Backend and put all of this code into that folder. If we type in ls, we can see that this folder has been made. So now I'm going to go into VS Code and I'm going to open up that folder. So now that we have the project opened up in VS Code, what we'll want to do is open up a terminal and set the new origin of our repo to point to our collection here, or our repository. To do that, we can copy this line here and paste it into the terminal. However, before we hit enter, we want to change add to be set URL, because we are changing the URL rather than just adding it. Now, what we can do is say git push origin master, and that'll push the origin or the master branch to our new repository. As you can see, it's pushing now. Now, if we go back to our page and refresh the repository, you'll see that all of the code is now here, and it essentially matches the old repo that we provided. This way, you can make as many changes as you want, and it won't be reflected in our template. Now, moving on, I'd like to set up our Python virtual environment. To do that, we can copy the line that I have provided here and paste it into the terminal. In Python, when you install packages, it installs them globally, and since you might be working on several different projects at once, that can get messy since you'll be installing a lot of different dependencies. What this does is it allows you to localize all of the dependencies within an environmental folder called env, which you can see here. Now we'll want to make sure to activate that virtual environment by copying and pasting that line. You'll notice that the environment is activated when there's a parentheses env here. From there, you can install all of the project dependencies by running this command. This command looks at this file here, requirements.txt, and installs all of these dependencies. This might take a little bit of time. All right, once that is finished, you should be set all ready to go. I can now show you also how to set up a debugger in VS Code to run your project. So if you'd like, you can run the project without a debugger by just typing in these two words here. Oops, before you do that, you want to make sure to set up your environmental variable, which I talked about in the previous video. To do that, we provided an environmental file called .env.sample. What you'll want to do is right-click, copy, and paste it in. From there, you'll want to rename it and delete all of it except for .env. Within this environmental folder, you'll notice that there's a key and value pair. The key in this case is Mongo URI, and this is what we'll be using to connect to our Mongo database. We've provided one for you, so you don't have to mess with that right now. We'll get into that in a future video. So let's try that command again. There you go. Now it's working. So we can open up this link that's running locally on our machine by pressing Command and click. It's probably different on Windows. What we can see here is pretty much an empty window that says "Welcome to my ZotHacks 2020 project." So if we start to take a look at inside the code, let's see what it's actually doing. Alright, so we start off with app.py. This is kind of the root of our entire project and where everything kind of starts off from. First, you'll notice the first line that runs is load.env. This is what loads in our environmental variables from the .env that we provided here. From there, we create an object called app, which is essentially our Flask object. Then we make sure to allow cores to access the API. And that's just as simple as passing the app to a cores function, which we import as part of our dependencies. From there, we'll make sure to set the Mongo URI that we had set in our environmental variables into our Flask app config by using this line right here. Then we'll also set a custom JSON encoder, and I won't get into too much about what this is, but I'll come back to it later. Then we'll want to initialize our database by passing it the app object, the Flask app object. And then we'll want to also pass the Flask app object into a function called API, which will help us create the Flask or the REST endpoints that we'll see in a couple minutes. From there, we're going to add a resource. Specifically, like we mentioned before, we have a user resource, which again, I'll get to specifics in a little bit. And that'll be found at the /user path, which we saw in the Postman collection in the first video. So now, this is what we actually just saw on this empty page here. We saw, "Welcome to my ZotHacks 2020 project." This is vanilla Flask, meaning there's no additional libraries in here. This is what Flask provides. The majority of this project moving forward will be using a library called Flask RESTful, which provides a lot of nice kind of functions and classes that makes our backend a little bit easier to understand. But I also wanted to provide one vanilla Flask route just so you have an idea of how it looks like. So in this case, this route is just an empty path, which you can see here is why it defaulted to it when we navigated to the base URL. It takes methods get, so it only works on a GET request, which happens to be when you log in, when you use your browser URL, when you open up a new tab, this is always a GET request. And all it does is whenever a user navigates to that page, it returns this text. Pretty easy. Now I'll go into what the error handlers are in a little bit, and you might be able to guess what they do, but I'll come back to that in a little bit. I also wanted to quickly show you what's in the db.py, and there's not a lot here. All we do is import an object from the PyMongo library, and we set it equal to a Mongo variable. This was important because within app.py, we imported this within right here, import db, which imports this file. And then we called db.mongo, which was that variable we saw here. And we had knitted the app with the Flask app that we have here. So these two files here kind of are the base of our entire project. I'll now go into the actual resources themselves, or specifically user. So there's a lot of different classes we can see here, but the one that we're really going to care about from the start is the one that's called just user, and that's our actual resource. Now, within our user resource, we have 4 different functions. The ones you might recognize are get, post, put, and delete, as they match up with the different types of requests that you can make and that we saw in the first video with the postman requests. So what we'll want to do first is, what we should have done actually earlier is after we initialize our environment, we'll want to set to tell VS Code that we've done that. And we can do that by clicking the Python part right here and selecting where we saved our environment. In this case, it's typically within the env folder, and it's got env in parentheses here. So we can click on that. And this will make sure that when we use the debugger, it'll make sure to use all of the dependencies that we installed earlier. So in order to run the debugger, we can click to the debug tab here and click create a launch.json file. Once we click Flask, all of these default settings pretty much work for us, and we can just close out of this and we can hit play. So as you can see here, it says serving Flask app.py. Ignore all the part up here, and it's running on the same address that we were running at before. So if we go back, we can refresh this page and see that the website is still up. Now, if we were to try to debug maybe our backend, maybe we were having issues, we can just add a breakpoint on any line. Like for example, if I added a breakpoint here and I refresh the page, you'll notice that it'll hang, and it's because it hit the breakpoint right here. And the nice part is that I can actually see all of the local variables and any of the information that I want here. And I can even debug by using some of the values that we have stored. Right now we don't have any values stored because it's a simple endpoint, but this is going to be more useful when we check out the user resource. So I'm going to stop the debugger for right now. And in doing so, it'll kill the website. So once we go back to the user resource, we can kind of take a look at what's exactly going on here. So let's take a look at specifically get. It looks like it has a decorator right above the get function that says use args get schema location query string. Let's also take a look at our postman collection that we saw earlier. As you can remember, we used query parameters, which we set and were URL encoded in the URL, in order to specify what our search was going to be. So what this is saying here is we're looking for information that follows the getSchema class, which we can see up here, and is located in the query string. So let's take another look at that getSchema here. So we have 4 attributes: ID, email, first name, and last name. ID is a function field, which might look a little strange at first, but I'll get into that in a little bit. Then we have email, which is an email field. And the nice part of making this an email field rather than just a string field, as we can see below with first name and last name, is that the library that we're actually using, in this case I think it's Marshmallow, it'll actually validate the value that the user provides to make sure that it's a valid email, which is pretty nice. And I can show you that right now. And if we wanted to use Postman to hit our endpoints here, what we'll want to do is we're going to want to start up the server again. You can see that it started up here. And we'll go to the Postman and we'll create a new environment and we'll call it local. And we'll set URL again and we'll grab the URL here. And again, we'll remove the ending slash. This will make it so that way we can keep the old environment, which had a value here. So this was deployed on Heroku. But since we want to be able to debug, we want to create a new environment variable, which has the value of that we're actually hosting it on, which in this case is this address here. So now we'll switch our environment by clicking local, and we'll try to run it again. Let's get rid of this ID parameter. So as you can see here, we got 2 results back, and that's because we're using the database that's stored in the cloud, right? Remember that database, that URI that we had set here? This is currently stored in the cloud. This allows us to connect to it. This is the username and this is the password. So now that we can add breakpoints, let's try adding a breakpoint within the GET request here and seeing what happens. So as you can see, the request is hanging. It's stuck on sending request, and there's a yellow bar to indicate that the endpoint was hit, or the breakpoint was hit. Now we can step over this line, or we can add another breakpoint and step over it. And we can click, and we can copy paste users. And in the debug console, we can paste in users, and it'll just tell us, it'll provide the Python value for what that variable is. So in this case, the API currently found from the database, which this queried, two object users. In this case, we have in the first index and the 0th index, we have attribute underscore ID, first name, last name, email. And if I let this continue, you'll notice that these results seem very similar and that they match up. So this endpoint here is pretty simple. The most complicated part is that it performs validation and it hits the database. So I was telling you before, if I provide maybe an invalid email, maybe I just say something like this, it'll actually tell me that the email is not a valid address. It needs to have the at gmail.com, something like that. And then now it'll actually try to hit the the server and try to find any users. Obviously though, we're not going to have any users with that email. But nonetheless, it's pretty nice that it does that kind of validation for us. Helps kind of fix, silly bugs down the road. So that's pretty much the GET endpoint. The main thing to keep in mind is that we're using the schema here, which validates against these attributes. And again, even if I were to maybe add a wrong attribute, like let's say for example we had test, what happens here? And let's get rid of the breakpoint for now. Unknown field. So again, unless it follows this exact schema, the endpoint will reject it. It has to follow this kind of pattern here. So once it gathers all of this information, it passes this kind of serialized schema into something called query, which then gets passed to the Mongo database and that we can search by. And this is just and actually we can tell what this is. Let's try hitting it again and seeing it. Oops, it did not hit it because the validation was wrong. We hit it now. We can see by hovering over it that query is just an empty curly brackets. This is just a dictionary in Python that's empty. And this is because we didn't provide any query string parameters. So that's pretty much all there is to it for GET. And after that, after we get the array of users, we JSONify it, which means turns it into a JSON object with the key data and the value or array of users. Now let's take a look at post. Post is pretty similar to GET in terms of how they're organized. However, instead of using GET schema, we use post schema, and instead of the location of the data being in the query string, it's in JSON. And in this case, JSON really just means that it's in the body, right? This was our JSON object that we're passing it. So let's add a breakpoint here and see what happens. So if we take a look at body now, we'll see a dictionary with 3 values, first name, last name, email, and that it was validated against the post schema. The post schema in this case is pretty similar to the GET schema, except it doesn't have this ID attribute, and each of the fields are required, whereas in this place, none of the fields were required. From there, it just simply inserts the provided information into our Mongo database and returns similarly to how we returned in the GET request. So let's continue and see what it returned. Let me split screen this so that maybe you can get a better idea and I don't have to constantly switch back and forth. Okay, so now let's take a look at the put request. So the put request is a little bit more complicated because we're using two separate schemas. Remember, if we look at the put request here on the right hand side, we have query parameters of ID as well as a body that we provide, which is why we need to have two different schemas set up. So if you take a look at the put query schema, all it's got is ID and it's required. And we've got the put body schema. Put body schema is very similar to the post schema in that everything is also required, which we can see here. So if we were to add a breakpoint here, and let's copy that from that request we just made. Let's copy that ID and let's update it. So you can see it hit the endpoint here. If we take a look outside query, we'll see that single query string object, right? The underscore ID, which matches this. And then we'll also see the body, which is new test user, which we can see here, new test user. So what this will do now is it'll find, using the Mongo database, it'll find the entry that matches with this ID, and it'll set it to all the values that we provided in the body of the request. From there, it'll then search to find that very user we just updated and then display it in JSON form, like we saw in all the other requests, like so. From there, if we take a look at delete schema, it's pretty similar to the other ones we were looking at in that it just takes ID and that it's required. So let's try taking a look at that, and I'll add a breakpoint here. So it hit the breakpoint, and all Mongo does now is find the user with this ID and deletes it, and then returns the message, user was deleted. And we can see that here. So for each one of these different kinds of endpoints, get, post, put, delete, we create a schema for each one of these. And in the cases where there's two different locations of data, we create two different schemas. Now, I think all of this should be pretty clear by now. However, the one thing that I didn't really go into was this fields function thing. This might be a little bit strange because why would we need it? Why don't we just use fields.string for the ID, since essentially the ID is just a long string? Well, as it turns out, Mongo is a little bit picky when it comes to object IDs. So let's kind of show you what I mean. So if I go back to the get endpoint and I try making the same request, what it'll do is this function will take the string and it'll actually deserialize it into a Mongo object ID. So if we take a look here, we'll notice we can actually let's go to query, and you can see here it says object ID and then the string. So the string that we have here is already wrapped in an object ID, and that's because this function, Mongo ID decoder, has already ran and has converted the string that we provided into an object ID object in Python. We can check out in the util.py folder, file, and we can see that all it's doing is taking whatever object it passes it and wrapping it in this object ID function and then returning it. And if for whatever reason this fails, it returns an error saying invalid user ID format. Let's kind of see what maybe that might look like. So if I were to restart the server and try to run this again, but notice how I added an A at the end of the ID. Invalid ID format. This is because when trying to encode into an object ID, it knows that the ID should have this length. If I delete it, it'll work again. So the main reason we need to convert into an object ID is so that when we use any of the MongoDB functions such as find or insert one or find one or delete one, it needs to have the object ID. It will not accept a string in place of the ID. So that's pretty much all there is to that. All it does is take a string and encode it into an object ID, the specific object ID that Mongo requires. So the last step of this is, now that we've on request, now that our API, when receiving an ID string, converts it into an object ID, when we return the information back to the user, we need to convert that object ID back into a string. So we convert a string into an object ID, and then we convert that object ID back into a string for the endpoint. Otherwise, it doesn't print correctly and it doesn't work. So if you remember, within app.py, I showed you JSON encoder, and I said that I'd explain it later. So what this does is, in the case that one of the attributes within the JSON object we provide is an object ID, it simply casts it as a string and returns it. So this does the opposite of this function down here. So that's pretty much all there is to it in this API, or Flask Server. All of the endpoints are pretty self-explanatory, I think. And if you have any questions, please make sure to contact hack@UCI, and we'll try to help you out. And we'll make sure that we hope that you have a great time at ZotHacks 2020.